The BLDC blower motor in a Sharp mini-split air conditioner often jams, causing it to malfunction. So, I will replace this motor with one from another brand and show you how to make the wiring connections to install it with the new motor. Now let me explain the issues that occur with it. This motor is rotating freely, but this jammed motor is the second motor. I'm rotating its shaft and it's turning stiffly. I have another motor like this, and I will explain the situation. You can see that I have opened the PCB from the top, and it looks perfectly fine. There is no issue with the PCB. A common problem that comes from this IPM is that it can fail. When the IPM burns out, it is necessary to replace it, but this IPM is not readily available in our local market, so the entire motor needs to be changed. So let me explain how to change this motor. First, we will understand its board to see how it's working, then the motor, and finally, how to install the other motor. First, safety is the most important thing I want to tell you. I have turned the unit on, and there is electricity present. The motor has also started running. You can see that the motor shaft is rotating. Now, the safety precautions you need to take, and what you should never do, is to avoid trying to remove or reconnect this connector when electricity is present. It's easy to disconnect, but if you reconnect it while the electricity is on, your motor may burn out immediately. Now, as the connector went out, the motor stopped. Before installing the other motor, we must understand the PCB and this connector. Let me show you the connector first. When we closely examine the connector, we can see there are 7 holes, and because there are 7 holes, 7 wires can be installed here. However, most motors are DC motors that operate with 5 wires. In this case, 5 wires are connected, but you can see that their positions are different. You have 1, 2, 3, and then 4 is empty. In the 5th position, a wire is connected, the 6th is empty, and the 7th has a wire attached. Therefore, your PCB can have different positions and the wire colors vary. As I explain further, you will understand better. Now, when we look at this PCB, you can see that the connector CN8 has a blue mark indicating pin 1, followed by 2, 3, 4, and 5, which you can observe physically. The 6th number pin is not present in the connector, and then pin 7 is connected. But the other connector has 5 pins. So what's happening here? I will explain that too. We need to turn the PCB over and check the backside to understand the system. You can see here that there shouldn't be any confusion because confusion can lead to problems. Pins 1, 2, and 3 are connected, but pin 4 is present, although it is not connected to the circuit. 5 are connected, and pin 6 is empty. It's not present at all, while pin 7 is connected. This means there are 5 pins present, but we can see 6 pins, so again, there shouldn't be any confusion here. Now that's clear. Now, let's understand the connector CN8 and the wire's functions to make it more accessible to install the other motor. You can see the numbers from 1 to 7 marked here. Pin 7 should receive 320 volts. If 320 DC volts are coming through, it means the voltage on this wire is fine. Pin 6 is empty, while pin 5 is for the ground connection. Then pin 4 is also empty, but the next pin is PG, which stands for pulse generation. This means pulses are generated here and go to the microcontroller as feedback, indicating the speed, RPM, at which the motor is running. After that, pin 2 is the VCC pin, meaning plus 15 volts should be supplied here. If plus 15 volts come here, it is correct, and the motor will operate well. Let's discuss the last pin, pin 1. This is the VS pin, which provides the control voltages necessary for running this motor. The microcontroller will supply those voltages, and the motor will start. Adjusting the voltages can directly control its RPM from this pin. Now we can install the motor in 2 ways. Often, these motors have a sticker, making them very easy to identify. The sticker has all the details written on it, including the FG and 15 volts, allowing you to recognize which wire goes where and what it does. Here, I have also written the wire colors for easy identification. The second motor, usually installed in the higher inverter mini splits, also has a sticker so we can quickly determine everything. You can use Google Translate to understand it if it's written in Chinese. If you have a multimedia camera, you can translate it using that to see which wire is for what purpose. However, there is a difference to note. The connector type and arrangement are different. Only the wires used are the same. You can see that a blue wire is installed after the yellow wire, followed by white, black, and red. If we look at the original motor inside the Sharp unit, the yellow and white cables are present, whereas the yellow and blue are used in the new motor. This means the motor will function similarly if you connect the same wires. I have another motor that I just opened from an O General unit. Its blower is not coming off, so I'm also showing you this one. You can see that this motor is also rated at 30 watts, just like the Sharp motor, so it doesn't matter if it's a little bigger or smaller. You can also see that all the points are present here, and one common thing is that the wire colors used in both motors are the same. The same wires are used in the O-General unit. However, the arrangement is different: blue, yellow, white. But if you look at it from below, you'll see yellow, white, and blue. So don't get confused. It doesn't matter because the internal wiring system is the same. Only the connector has been reversed, which may make you think we cannot install it. However, this motor can be installed, and if the same wires are connected, it will work perfectly. I've had a lot of experience with motors and replaced many Sharp motors that work perfectly. Let me explain that some motors come without detailed labeling, and only a few things like KFD 28048F are written on them. However, if the wire color codes are the same, there's no problem. You just need to cut the wires and use this connector to join a separate wire, and you'll have the same function available. But if the motor here is completely different, like the wire colors, then I'll explain the details to you, what each wire does, and how you can easily identify it. If I discuss this motor further, I've already explained that if the wire colors are the same, then everything will be the same. But if there is a difference, how do you handle it? Look carefully at the positioning here. There's a gap of 2 wires between the pink and blue wires. This gap is always maintained because of high voltages, 320 volts, and the other wire is ground. The gap is kept to avoid any short circuits. However, some companies provide less space to create more miniature connectors, making it challenging to identify which wire is for what. Then we have 3 other cables, and their identification is also different. How do we recognize them? I'll explain, because without understanding the circuit, you cannot identify them. You'll notice that some motors have red and black wires instead of those with pink and blue wires. So you'll join the black wire with the blue and the pink wire with the red one. This completes the work. Now, what about the remaining 3 wires? There's blue, white, and yellow. Here's what we'll do. The white wire is for PG, pulse generation, which receives 15 volts, but we'll need to connect it to the blue wire. The center one, which is yellow, is for VS, voltage supply, so it needs to be joined with the yellow wire. Finally, the brown wire is for the 15 volts and should be connected to the white wire. This completes the wiring setup. Now, let me mention one more small point. Often, my viewers point out my minor mistakes, so I would like to say that you should also use a little common sense. For example, I see yellow and orange wires here, so I initially said yellow, but now I wrote orange. So using common sense will help you understand things quickly. I've written down all the color codes here. If you connect the wires in this order, the motor will start working flawlessly. So let's go ahead and test it. Now you can see that I have made all the necessary settings. This is the indoor unit of O-General, but without its original circuit, and I've used a Sharp circuit with it. I have connected the same color-coded wires to it. Now, let's start it. As you can see, it has turned on, and the blower motor has started running perfectly. The PCB is also efficiently controlling the motor's speed. Now, let's discuss whether a Daikin motor works with a Sharp PCB. The motor currently installed is indeed from Daikin, and just as I told you, I connected the wires in the same way, and when I started it, the blower is rotating and it is working perfectly. The functions are also working well, so you can set it up this way too, but there are some other color codes used, so it's very important to check the specific wiring diagram for that. Be cautious about that, but mostly, these 2 systems are used. Click on the left or right thumbnail to watch our next videos, and subscribe. Thank you.